Okay, so let's go ahead and do some more. Just before we do more, I want to take note of the patterns we've seen. So the big patterns is that cosine, sine, secant, and not that you know this because we haven't done all of these, but all four of these, remember your period is 2 pi, and you'll often have multiple answers. Okay? So usually you're looking for 2. Sometimes that's actually not the case, and I'm sure I'll find an example of that later on in this video. While tangent and cotangent, you'll have a period of pi, and there's only one answer. Okay, so just be aware of that. Just a little side note. So we're in a cosecant problem. So like all the others, I'm going to go ahead and solve. Divide by 3. So you get -2. Then I'll apply the inverse. So that's this. And then, since it's a cosecant, I will have multiple answers. So I'm going to go ahead and do my first and second one. So, cosecant says that that it's going to be the reciprocal of our y. So 1 over y equals -2, meaning y is going to be -2, or -1/2, sorry. So I'm looking for a y value of -1/2, so we've got one right here, and then one over here. So remember when I use the fourth quadrant, I like to use the negative angles, so I'll go ahead and do -pi6. And then right here we've got 7 pi6. The period is 2 pi, so I'll put just 2 pi k for both of those. And then the last thing I need to do, because we just wrote this all down, I'm going to go ahead and divide everything by 2. So we've got theta 1 equals -pi/12 plus pi k, and theta 2 is going to equal 7 pi/12 plus pi k. Okay, so those are the general equations. However, take note, it tells us that we aren't telling us the general equations. We need to list 4 solutions. Okay, so down here I'm going to go ahead and put my 4 solutions. Okay, so 2 of them are just the -pi/12 and the 7 pi/12. Those ones are easy. Okay, so I'm just taking these numbers right here. To find our next one, I'm going to go ahead and take -pi/12 and add pi to it. That'll give me 11 pi/12. Okay, so we've got this one, we've got this one, we've got this one. And then for my last one, I'm going to do the same thing. And the reason I'm adding pi is because that's what it's saying right here. Last, I'm going to take 7 pi/12 and add pi. And so 7 plus 12 over 12 is 19 over 12. And there's our 4th solution. You could also subtract pi if you wanted, it doesn't matter. Okay. So that's what it means if it tells you to list 4 solutions. So let's go ahead and solve this one and do the same thing. So we're going to do both. And we're doing a secant, so I'll subtract 3. 4 secant squared of theta is equal to 8, because I can do math. Really good at it. And then we've got secant squared of theta equals 2. Now to get rid of the square, I will have to take the square root. And when you take a square root, don't forget that you have a positive and negative answer. So plus or minus square root of 2. Next thing I'm going to do is apply the inverse. Now notice we are doing two different values in here. So I'm going to be doing the 2 angles for positive square root of 2 and also 2 angles for negative square root of 2. So there should be a total of 4 angles. And since they told us to list 4 solutions, it's going to be super easy to do this. Okay, so let's first do our general equations. and then we'll just list out those 4 angles we found. So secant is the same thing as, or it's the reciprocal of our x values. So 1 over x is square root of 2, so x is going to be square root of 2 over 2. Okay, so we're going to go, and we're finding it for both positive, and I should have put a plus or minus in front of those. We're going to be looking for all of the x values that have a square root of 2 over 2 in them, whether they are positive or negative. So we've got pi fourths, we've got 3 pi fourths, we've got 5 pi fourths, and we've got negative pi fourths. That's the 7 pi fourths. I don't care if you put 7 pi fourths, but I like to use the negative angle when I'm doing inverses, just so I am in that practice when I'm evaluating. And then secant's period is 2 pi, so I'll put a little 2 pi k at the end. And we don't have to divide by anything, so we are good to go. So this would be our solution, and then the 4 solutions, I would just write the pi fourths, the 3 pi fourths, the 5 pi fourths, and the negative pi fourths. Okay, and remember that could also just be 7 pi fourths if you wanted. Okay, let's go back to just writing general equations, but let's do some fun ones, you know. So this one, sine, is, we've already got it isolated. So we're going to go ahead and apply the inverse. And let's see if there's a second one. So there's 1, there's 2, and, oh, I should have written this out. Sine, oops. Theta over 2 plus pi 6 equals, I'm just playing the inverse right here. And so then we got our answers. Okay, so sine is the y value. So I'm looking for a y value of 1. So if you notice, there's actually not a second one, so we don't need this one. We're going to go ahead and just use the pi halves, and then I'll add my period, the 2 pi k, and then we're going to go ahead and solve this. And since there's not a second one, I'm going to move that. I'll move it down here. Okay. So we'll solve this first equation by first subtracting pi 6. I'm just doing it to like terms, so I'm not going to subtract it over here. So so we got theta over 2 equals a half minus a sixth is 2/6 or a third. And then the last thing I'm going to do is multiply by 2. So I'm going to multiply everything by 2. So theta is going to equal 2 pi thirds plus 4 pi k. And that would be my general solution. And so notice this is a rare case where sine actually only gave you one angle that works. And that's because there's no other place on the unit circle that's going to give you a y value of 1. So to sum up, let's go back to where I wanted to sum up. Sine, cosine, secant, and cosecant all have a period of 2 pi, and you will have multiple answers, usually at least 2. But sometimes it's just 1, like that last problem. Tangent and cotangent have a period of pi, and there's only 1 answer at the end. And that is that.